Hi, how are you?
Hello, Professor.
Hi.
Hi, Professor.
How is everything? Is everything fine?
Everything's good.
Good. So,
So, Professor,
yes,
the quiz today we have to finish by tonight, right?
I'm going to put for most of the people from 4 to 6, they agree to do it for 4 to 6. And those who cannot do it for 4 to 6, just send me a text message and I will tell me the time that you need and I will open it today.
Professor,
Yes,
so the people that are going to take the quiz later, they're still going to have the same 2 hours or they're going to have more time?
if they need more time, I don't mind.
So then why don't you just open it for everybody from 4 until the end of the day?
From 4 p.m. until the end of the day is what time is?
11:50, how you always do it.
Yes, but I prefer to narrow the time that you need to do it because it will be for me easier to see the result. Okay, so I will open from 4 to 6 for everybody, and those who cannot do it from 4 just you let me know and I will write at the time that you can do it. Okay, it's so easy as this. No headache for anyone. Just write me an email, tell me I'll be ready from 7 to 9 and I will especially for those people 7 to 9. Okay.
Okay.
How what we have? Can we review what we have? Please help me with this because I forget sometimes things. Um, let me share my screen first.
Professor, I have a question. For some of the homeworks for Unit 5, can you go over how to find the displacement and the force of an object when you can only find the work, when you only have the work given and we have the mass and the two velocity values?
Can you tell me exactly which problem is this one?
From homework,
5.3.
yes, 5.3 for question C.
Yeah. Can I see it? Can I see the questions? Let me see the question, please. Just a moment. I go to modules, yes, to 5.3.
Yes.
Yes.
5.3, 5.3, the theorem of work and energy, and you need me to go to the last part of the video, and it say a problem. Which name of problem? Or is a problem that I made by myself?
It's the problem that you made. It's part C of the question.
Okay, can you tell me exactly what it's because I don't remember?
So the question gives the scenario where the object has a velocity 1 of 10 meters per second and the mass is 1 kilogram, and then after a distance, some displacement that is unknown, the object's velocity increases to 100 meters per second.
So
And then part C is asking what is the displacement that is unknown.
repeat again. The mass is 1 kilogram.
The mass is 1 kilogram, velocity 1 is 10 meters per second, and velocity 2 is 100 meters per second.
So, and what happened?
So in part A asks you to just find the work, and then part B asks you to find what force creates the work, and then part C asks what is the displacement.
Okay. So let's go to do this homework. Part A. Part A. I have an object of mass m. The object is with certain velocity v sub I, 10 meters per second, and finally he ends with a velocity of 100 meters per second. For sure, there is some external agent that have done work on the object and has created the variation of the kinetic energy. The work done is the variation of the kinetic energy. For sure that the work done is 1/2 mv final square by mv initial square. For sure, the work done is 1/2, the mass is 1, the velocity final is 100 square minus 1/2, the mass is 1 by 10 square. So this will be whatever joules. So it will be 110,000 divided by 2 is 5,000 minus 100 divided by 2 minus 50, right?
It's 4,950, Professor.
4,950 joules. So the work done by the force that is acting on the body has kinetic energy, and the work that the force have done is 495.50. On part B, it say, well, tell me, what is the force that create this energy? B is asking you, and C is asking you
The displacement.
displacement. Well, it's a question to make you to think. Any force that make this displacement will create 490.50 joules positive. So the force and the displacement is in the same direction. But what force and what displacement will make 490.50 joules? Well, maybe 10 by 490.50, maybe 190.50 by 10, maybe any combination of force and displacement that the multiplication is 490.50. So the question makes you to think that you have the value of the work, but you don't know what is the force, and you don't know what is the displacement. You know the possibility. You know that one possibility that the force is 10 and the displacement is 195. You know another possibility that the force is 495 newtons and the displacement is 10. But you don't know for sure what is the force and what is the displacement. What you know is that you saw an object with initial kinetic energy of 50 joules, and you saw an object finally with kinetic energy of 5,000. And now you know that for sure some work must be have done on the object. But you don't know what is the force, you don't know what is the displacement. What you know is that the sum of all the forces make a work, and this work is related with the variation of the kinetic energy. Okay, so this problem is, this question is a little bit tricky just to make you to think that there are many possibilities here to answer, okay?
Well, Professor, in all honesty, that's a little frustrating because in the video you said that we would be able to find the values of the force and the displacement. So like we just how would we know to expect that we would just list the possibility of those answers?
Well, you can find the value, force, displacement, and work. 495. Displacement 10, total work 490.50. Well, 10, you can find 495 and 490.50.
But that's not different than what you were just doing.
Well, I don't remember what I asked you on the part B and C. Can you tell me exactly what I have
Hey.
to do? I don't know what I was thinking when I made this question. Can you?
So part A asked us to find the work, which we found, and part B asks us to find what force creates that work. And then part C asks us to find the displacement. Now part C is easy if we know the force. But if we don't know the exact force, we won't know the exact displacement.
Well, the point is that part B asks you what force will make this work. The answer is you cannot know what force will make the work. The combination of the force and the displacement have to be like this number, 149. 49.50. If you displace 49.50 at 100 meters, you get 490.50. If you displace 49, if you have a force that of 49.50 and you displace 100, you get a work of 490.50. So the question is here is that the variation of the kinetic energy is the same in all the cases. The variation is all the same, so the possibilities are many. It's a question that has no one answer. It's a question that it depends. If you fix me the force, I can tell you the displacement. If you fix me the displacement, I can tell you the force. But if you don't fix me the force and the displacement, I cannot tell you exactly what is the work that have done, what is the force that have done this work. That's the point, okay? And maybe,
Okay, thank you, Professor.
Maybe it was not proposed the question in a good way. I don't remember. I'm sorry that I don't remember how I asked you the question. Maybe it was confusing for you. I don't remember. I will review it again how I did the question, okay? Okay, let me remember something. First, let me to review what we have in mind. Today, we have quiz 5, correct?
Yep.
When we have quiz 6?
Tuesday.
Tuesday, we have quiz 6. Quiz 5 will be about work. Tuesday, you want to put this quiz on Thursday? Would you like?
No. Tuesday seems fine.
Yeah, because it wouldn't make sense to take a quiz after the test.
Okay.
Yeah, Tuesday's fine.
The quiz on Tuesday will be about rotation. Okay, rotation laws. Okay? Dynamic of rotation. On Thursday, we have test 2. Correct?
Yeah.
What else we have?
I think that's it, no?
That's it.
We have Unit 5 homework and Unit 6 homework.
I
Yeah.
have to upload quiz 5, quiz 6, and test 2, right? I have to do this.
Yes.
Can you remind me if there is something that I'm forgetting maybe? Should I do anything else?
You're just missing the Unit 5 and 6 homework, but I think that's already up, or you're just missing Unit 6.
Unit 6 is...
I think you have to upload Unit 6, Professor.
Unit 6 is going to be uploaded, I hope, tonight, and you will have all the homework for Unit 6 tonight, okay? I think that I finished with Unit 5, and I put the homework for Unit 5. So what is left is 5, load, Unit 6. Okay, what else? Should I forgetting anything?
I think you got everything covered, Professor.
Yes, if there is something that I'm forgetting, you know. So let's go to,
Professor,
yes,
Unit 5 homework is due today or tomorrow or Saturday.
the homework for you, what?
Unit 5, is that due tomorrow or Saturday?
Do tomorrow.
Okay.
It's, I did it like this because I want to finish Unit 5, start Unit 6. So on Saturday and Sunday, I want you to have your mind free, not to have so many stress, and you have the whole, almost the whole week, Saturday, Sunday, Monday, Tuesday, and Wednesday to prepare the Unit 6 that is going to be on the test.
Okay, Professor, I understand.
I did it like this because I consider it was the best.
I think so as well, Professor.
Okay, so let's go to cover the material for Unit 6. Don't worry that you will find all the videos for Unit 6 step by step, explain with examples and with everything. So what we have done for the moment? For the moment, we have defined omega. How we have defined the angular velocity, like the angular displacement divided by delta t. This is the angular velocity. Second thing that we have defined is the angular acceleration. How we have defined the angular acceleration? The change in omega divided by the change in time. This is the angular acceleration. When omega change, there is an acceleration alpha, and this is measured in radians per second, and this is measured in radians per second square. Third thing that we have said that omega can be considered a vector. What vector? This vector. The body is rotating through an axis. We imagine a vector on the axis, parallel to the axis, and of course perpendicular to the body. This is the second thing that we have seen. The fourth things that I have seen also, alpha is also a vector. Is the change in omega divided by the change of time. But these vectors, usually you will not need it to treat it as a vector, because the axis where alpha, you see on the axis is omega. So this is omega 1, and let's say this is omega 2, the second angular velocity, final angular velocity. So the change is this vector. This is the change delta omega. So delta omega divided by delta t is the angular vector acceleration. So this is alpha. Catch it? So, more things that we have seen. 5. We have seen that the moment of inertia through an axis, moment of inertia through an axis is defined as the sum of m sub I by r sub I squared, the sum in I. So I, the moment of inertia, is m1 by r1 squared plus m2 by r2 squared, etc. until the last math where r is the distance is the shorter distance between the mass and the axis. So if the body is rotating like this, and I consider this mass, r is this distance, the distance that is perpendicular to the axis. The distance perpendicular to the axis. This is the Ri if this is the mass Mi. So if this is the mass, so is the distance perpendicular, Rk, Mk. Okay? This is the mass. What else we have seen? We have seen that based on the momentum of inertia, the kinetic energy, the total kinetic energy, the sum of all the small kinetic energy of the particle, E sub k1 plus E sub k2, can be writing like 1/2 moment of inertia by omega squared. This we have seen. What else we have seen? Oh, we have seen also that 7 L is equal R cross P, and if you have a mass, if you have a solid, an object, and you want to calculate L, very important this, O, this is the point O. The angular momentum, L, the angular momentum is calculated respect to a point, because it's not the same to calculate it R cross P from this point that to calculate it the same quantity on this point O prime. You choose always a point on the axis to calculate L. So what we have seen, that if we choose a point on the axis, L, that will be Ri is this vector, Pi is the vector because this is rotated like this, okay? Pi is this vector. What we have seen, Pi like this, Pi like this, Ri, what we have seen if we sum the individual moment of every particle, we sum R1 cross P1, or we sum plus R2 cross P2, etc., etc., we have seen that L is stay here on the axis. Why? Because first, the magnitude of L is the magnitude of this plus the magnitude of this. But this is true because R1 P1 is going up. Make the cross product of R1 with P1. Make the cross product of this R with this P that is on the plane XY. Let's go to put it like this. This is the object rotating through the theta axis. If you make R cross P, or MB, okay, R, the cross product will be a vector that is on the theta axis. So that's why L is the theta axis. So this is an L1Z, L2Z, always they are on the theta axis. So the magnitude of L is the magnitude of R by the magnitude of MV by the sine of 90 degrees, because when they are rotating, R and B, they make always 90 degrees for any points because they rotate it in a circle around the axis. So what we have proved is that the angular momentum, if you sum all these terms for all the particles, can be writing like I by omega. This is what we did last time. Did we do something else? Can you remind me if we did something else last day?
I don't think so, Professor. I think you were just covering this.
I stopped here, right? But I knew that I was doing one example that I don't remember. Stop me what we were calculating in one example. The angular momentum, maybe, of 3 particles?
Professor?
Yes.
Never mind. I'll ask at the end of class if I'm still here.
Okay. Okay. So let's go to do let's go to do 2 examples. One example. Right. One simple example to check that you are understanding. If alpha, the angular acceleration, is 5 radians per second squared. Question 1. Question 1. What is omega of t? What is the angular velocity? Second question. If alpha is 0 and omega is 2 radians per second, what is omega of t? Second question. Third question. If alpha is 5 radians per second squared, what it means 5 radians per second squared? It means that 5 radians per second. It means that the change in angular velocity per unit of time is 5 radians per second. So you increase the angular velocity in 5 radians per second in every second. So if alpha is 5 radians per second and theta 0 equal p divided by 4, what is theta of t? Okay? So I'll give you 5 minutes to do this problem. Is clear the problems? So the problem is like this. I give you alpha, the acceleration, 5 radians per second squared. So the angular velocity is changing 5 radians per second every second. So I know how it will be omega of t. Very easy to find omega of t. Because it's 5 by it's a similar problem as a position, velocity, and acceleration. It's very similar. So find omega of t. So if alpha is equal 0 and there is no acceleration, meaning that there is no change in omega, the time flow, but omega doesn't change. If alpha is 0 and omega initial is 2 radians per second, what will be omega of t? 3. What will be theta of t? Okay, so 2 different questions in the same problem. I'll give you 5 minutes to think about it. You want to discuss in group or you don't like to be in groups?
No,
No,
thank you.
just leave it.
I leave it. So please take 5 minutes and I want someone to solve this problem and to show his screen and show me how it's solved. Okay?
Professor, I have a question while everyone's solving the problem.
Yeah.
Are you going to have another day where we can talk to you about our grades?
Any day, anytime, you don't have to worry. I said that I can stay after class today and on Tuesday also after class and on Thursday after class and on Friday whatever you like and in the middle of the week if you are very, if you schedule another day on Sunday, you want to schedule a day to review the grade, with pleasure, I will do it. Do not worry about this.
Can I do it on Sunday, please? Because every other day I'm busy.
But Saskia, you have to schedule it with Danai because otherwise I will.
No problem. I will text her. Thank you.
You understand? I prefer if people they want on Sunday. I prefer to take care of, let's say, on 10 people on Sunday or 5 people or whatever they are interested from 10 to 11 or from the time that you like, from 1 to 2, I don't mind. But if not, I will be, I will be crazy. I will be crazy. Okay?
Okay, I'll ask Danae. Thank you.
Do this problem, please. I'll give you 5 minutes and I'll wait for you.
Professor, how many questions is the quiz today?
10 questions.
Okay. All multiple choice, correct?
Oh, yes.
Okay.
So, done? Should I start?
I'm a little confused on some of these, Professor, because it feels like some information is missing.
Maybe theta zero here. That's the only information that is missing, I think. Okay, let's go to do it. On this example that I'm putting, I say that alpha is 5 radians per second square. But alpha is the change in omega divided by the change of time. So the change in omega is simple alpha by delta t. So the change in omega is omega final minus omega initial. Omega final minus omega initial is 5 by delta t. 5 by delta t. So my equation says that omega is equal omega initial plus 5 times delta t. Let's go to find delta t is t final minus t initial. Let's go to put t initial equal 0 and t final equal t by omega t. So omega of t is omega initial. How much I said that it was omega initial? I didn't say. So we need this number to say, to fix the idea. So let's say that omega initial is 2 radians per second. 2 radians plus 5t. What does it mean this? It means that if you represent omega as a function of t, when t equals 0, omega is 2 radians. When t equals 1, omega is 5 plus 1 is 7. And if you represent for any times, you will get a rectilinear line. Is correct?
Yes.
It resembles something that you already know. If you have a equal 9.8 or minus or whatever, 5 meters per second square, and you draw v as a function of t, and v0 is 2 meters per second, it will not have the same graph? Is this not the same as this, but in angular velocity?
Yes, Professor.
You catch the idea? It's the same equation. So, once that we have discovered that we have the same equation, we have omega of t is a rectilinear line, 5t plus 2. What is theta of t? If we solve this problem, we have v final equal v initial, I said 2 in this case, plus the acceleration 5 by t. If I solve this problem for x of t, I will have x0 plus v0x plus 1/2 a by t squared. What do you think that I will have here? The same thing, theta 0 plus omega 0 by t plus 1/2 alpha t squared. So the similarity is that the alpha is the a, the v0x is the omega 0, and the theta 0 is the initial position. So what we have done is to solve this problem. So what is theta of t? Theta of t is theta of 0. Initially at time t0, we start with some angular position. Maybe theta is 0. Remember that theta is counting in this direction. If theta is 0, it means that the object is here. He is rotating in the plane xy through the theta axis. So this is the x-axis. Theta equals 0 means that the object is here. Theta equal pi over 2 means that this is pi over 2, and the object is rotating, and the angle is varying. It's changing the angle. How is changing the angle if theta, if there is an acceleration? Like theta 0, let's say that theta 0 is 0, plus omega 0 by t. Omega 0, let's say that omega 0 is 0. Initially, you start here with no velocity, no angular velocity, plus 1/2 5 t squared. So you can represent theta of t. And it will tell you what is the angle theta of t, what is the angle theta at any time t. For example, at 1 second, the angle will be 1 squared multiplied by 5 will be 5. 5 divided by 2 will be 5 over 2, 2.5. 2.5 what? Can you tell me?
Radians?
Radians, of course, means that in 1 second, at this acceleration means 5 radians per second square. So the acceleration is 5 radians per second square. That so means that this is the acceleration. So when t equal 1, 5 by 1 is 5, this is 7. 7 radians per second is the final angular velocity, and the angle displaced is 2.5 radians. So this problem is completely solved. Let's go to solve the other problem. The other problem is if alpha is equal 0 and omega 0 is equal to 2 radians per second. What is omega of t? Well, if alpha is 0, there is no change in the angular velocity. So how should be omega of t?
Wait, Professor, can I ask you a question?
Yes?
In the most recent problem you just did, how did you solve it without plugging in for t?
How did I solve what?
How did you solve for theta without plugging in for t?
I didn't solve. I said like this. In one dimension, I have the variable x, vx, and ax. If ax is constant, vx is v0x plus ax by t. If ax is constant, x of t is x0 plus v0x t plus 1/2 ax by t squared. So what I said is like this. If alpha is constant,
I understand, Professor. I'm just trying to, when you got the 2.5 radians, did you plug in anything for t, or was that just from?
Yes, I think I plug it here. So when t equal 1 second.
Okay. Thank you, Professor.
Okay, so what I did is, just to finish the idea, that I make like a pattern recognition. The pattern recognition is that the Vx is like omega, the omega z, because it's on the z direction. We are going to talk of the omega 0 z plus alpha z by t. So this equation is the same than this equation. So what I said, this equation, I have solved it. I have solved it for alpha because I said, if alpha is delta omega divided by delta t, this means that omega is omega 0 plus alpha t. I have solved it. So in order not to solve for theta of t, I have said that theta of t should be theta 0 plus omega 0 z by t plus 1/2 alpha z by t squared. It is a pattern recognition when the x is the theta, when the v is the omega, when the a is the alpha. This is the pattern recognition that I did. So if alpha is constant, and omega 0 is 2 radians per second, can you tell me me what is omega of any time t? Yes?
Yes.
Wow.
I said yes.
Yes? How much?
Yes.
Yes? Value of omega t if alpha is zero, not constant, is zero, and omega zero is 2 radians per second. What is omega of t?
2.
Of course, it will not change. So the graph will be like this. Alpha as a function of t will be this alpha, zero, always zero. And alpha, omega as a function of t will be always 2, no change. No change, because there is no acceleration. There is nothing that is accelerating the body. And how will be the graph for theta of t? Can you tell me? If omega is constant, how will be theta of t? Will be theta 0 plus omega 0 by t. It's the same thing that we did when we studied the movement with constant velocity. So, in this case, theta of t will be a rectilinear line when this is theta 0. Okay? You catch it, the idea?
Yeah,
Yes,
Professor.
Professor.
Okay, so we can continue. So the second thing that I want to make is to solve one example. And do not worry if you don't catch now, because I will remake this, all these ideas in video well structured, so you can go over the video by tonight or tomorrow, and you can review all the concepts one by one and do the homework. And the homework will open your mind to really understand what's going on, okay? So get the idea now, and when you see the video, everything will have more sense for you, I'm sure of that. But you have to make the effort to see the video, to do the homework again, and to focus on what I'm saying, okay? So the other example that I was doing was like this. I think it was around L, to find an L at distribution. Can you remind me what was? Let me see if I can. Maybe I can see here what I was doing. Maybe it was here. Maybe here. I think this was the last class. Maybe I can get the idea what I was doing. Well, I don't remember. Well, it doesn't matter. We'll. So what I want to do is, doesn't matter. Let's go to. So we are going to speak about torque. What is a torque?
The rotational velocity, rotational force.
It's related with rotations, yes. But what exactly is the definition of the torque? The definition of the torque is like this. Imagine this object. This is the axis of rotation. The axis of rotation is coming to your eyes. This is the object, okay? And the axis, I don't know, you imagine the axis, so this is the object, this is the axis, okay? This is another view. We are watching from here, okay? So this is the picture that I'm doing, okay? Correct? So let's say that you want to create a rotational movement. Let's say that you want to create a translational movement of this object. What you will do, you will put a force here, and the force, this will have a mass, and the force will create an acceleration, that is the force divided by the mass, and the object will start to move and to be accelerated. Do you agree?
Yes.
Yes, okay.
Oof.
Not what I want to do. My question is the following
I
one.
got you trying to kill him too. Oh my god.
Are you listening to me clearly?
Yeah. Saskia, mute your mic.
Is
I'm sorry.
good quality my sound?
Yes, Professor.
Okay. So what I want to do is, I have an object, and I want to apply a force and create a rotational movement here. And this is the axis. This is the axis. How can I make the force to create a rotational movement? If I leave the force like it is, I will not create any rotational movement. The object will be translated, will be accelerated, and you will find the object here with translation. There will not be rotational movement. So the question here is, what should I do to create a rotational movement? And the answer is torque. What it means, torque? Torque, it means that if you want to create a rotational movement on this object, you have to apply a force. But what force? If I apply this force, I will not create any rotational movement. You have to create a force in this direction, or in, but on this direction. So
Professor, could you mute everyone?
yes, let me mute everybody. Yes. Wow. Now everybody's mute. Just a moment. So I need to create a rotational movement on this object. The easiest way to create a rotational movement is to apply the force. This is the axis, this one, you see the axis, is to apply the force tangential. But if I apply like this, I will not create any movement. For example, if I'm here and I apply the force like this, I will not create any movement. But if I apply the force like this, tangential, I will create this rotational movement. So there is a magnitude that contain this information, contain the information that you are doing something on the object that generate rotation, that generate acceleration of the object. So the idea is like this. The torque is a vector, and the vector have a magnitude, and the magnitude of the vector is like this. The magnitude of r, this r, by the magnitude of the force, the applied force, let's say this one, by the sine of the angle. So, if F is parallel to r, the torque, the magnitude of the torque will be the magnitude of r. For example, in this case, r is here, F is here. It's parallel. R and F is parallel. The torque will be the magnitude of R by the magnitude of the force by the sine of the angle that they form, that is zero. But sine of 0 is 0, so the torque will be 0. So the torque is containing the information that a force that is parallel to the vector r cannot create a rotational movement. Indeed, cannot create an acceleration, angular acceleration. In Newton's law, force creates acceleration, linear acceleration. In rotational movement, torque creates rotational movement, acceleration. The torque is proportional to the alpha acceleration in the same way that the force is proportional to the linear acceleration. You catch the similarity that we are going to find. So, what happened? Oh, what happened here? What is that? Okay, what happened? The magnitude of the torque, I said, is the magnitude of r by the magnitude of the force by the sine of the angle. So I have my object here. My object is not a point particle like before. It's an object that has dimension, and I have an axis of rotation. This is the axis of rotation, is this one. I put it in blue, this one, the one that's going down or up, or whatever you want. I want to create a torque. So if I make the force like this is R, and now I make the force like this, I create the maximum torque. Why? Because in this case, the torque will be the magnitude of R, whatever it is, 5 meters, the magnitude of the force, whatever it is, 10 newtons, by the sine of 90. So will be magnitude of R by magnitude of F by 1. If I put this force at 45 degree between R and F, the torque will be magnitude of R by magnitude of F by the sine of 45 degree. But the sine of 45 degree is something that is between 0 and 1, so will be lower than this torque. Because this is with 1. This is maybe sine of 45 is 1 over square root of 2. Let me see. Yes, 1 over square root of 2. So this quantity is lower than when the force is perpendicular. So the magnitude, the vector that compile all this information is the torque, and is R cross F. This is the vectors that we are looking for in rotational movement. In rotational movement, we are looking for torque. If torque equals 0, there is no rotational movement. Or let's say alpha is 0. Okay? So if the force is 0, the acceleration is 0. It's something similar. Okay? So let's go to understand how to calculate. Let's go to the book, and we'll see a beautiful pictures how to calculate torque. Okay? Let me see. Let me review if I have something else to say before the torque. Let me review. Energy, because I expect to end today the class, if you allow me. Parallel axis theorem, you don't need it. Moment of inertia, you don't need it. Torque, okay, here. There are like 4 ways to visualize this equation. There are 4 ways to visualize this equation, R cross F. R cross F is a vector, is the vector that we call the torque, okay? And it has a magnitude and have a direction. The direction is the direction of rotate R through F and apply the rule of the right-hand side. Okay, for example, if you have the object and you apply R like this, F like this and R like this, so R cross F, this is R, also I put it here, R cross S will generate a torque in this direction. Do you see it? Do you see R cross F will generate a torque in the perpendicular to the plane formed with R and F. So the direction is the direction of the torque is the direction of the right hand tell you to do it. You rotate A cross B and you go in the direction of the right hand side. You know how we did it at the beginning of the course. So this is down. So now I'm worried about the part of the magnitude. So let's go to the book to find how to find the magnitude very easy. So for example, this is a machinery tool to screw or unscrew something, no? The first question, this force, what torque will do on this point? Well, the torque will be the R by the F. So will be the R cross F. And what is the magnitude? The magnitude is the magnitude of R by the magnitude of F by the sine of the angle that form R with F. In this case, R is here, R, and F is here. So the angle is 90 degrees between R and F. So it's sine of 1. So the torque of this force is going to rotate the screw in this direction. So it's going to be, the vector is going to be up, perpendicular to the screen of the iPod coming to my eyes. So the second question, the torque of this force is bigger or lower than this force, than the torque of this force? Well, the torque of this force will be R by F. Should be lower because the R is smaller. So the torque through this axis is smaller here than here. So if you want to create rotational movement, you will push on here or you will push on here. You will make the force at this point or you will make the force at this point. Huh?
Which point, Professor? I can't see.
The back. The end.
Yeah, I say that if you want to create a rotational movement on here, will you push? If you want to create an efficient rotational movement here, will you apply the same force on here or you will apply here? If you apply here, the torque is bigger because R is bigger. If you apply here, the torque is smaller because R is smaller. This is the R. So the point A has a bigger torque than the point B. So if the torque has a bigger magnitude at the point A and the point B that applying the force at the point A that applying the force at the point B, the torque through this axis will be bigger when I apply to the point A. If the torque is bigger, it's like the force. If the force is bigger, you create more acceleration, linear acceleration. Well, if the torque is bigger, we will see that you create more angular acceleration. Catch it? Yes?
Yes, yes.
Okay, so now, what is the torque of this force? The force that going directly to the axis that is pointing out. Well, the torque of this force will be the magnitude of R, this R, by the magnitude of the force, by the sine of the angle between R and F. What angles makes R and F?
90 degrees.
What is the angle between R and F?
90 degrees.
No, 90 degrees is this one. This one makes 90 degrees with R and F. Which
Oh, there is no angle. It's
R and F?
180.
180, of course. Of course. R is like this. Of course, 180. If R is like this and F is like this, the angle that makes, you can put it here, F, the angle is 90 degrees. If R is like this and F is like this, you can put it together, R and F, and you can see the angle is 0 degree. If in other case, if R is like this and F is like this, you can put it here, the F, and you can see that the angle that is for is 180. Okay? So if the angle is pi or 0, what is the sine of 0 or sine of pi? What is the sine of 0 or sine of pi? Is sine of 0 is 0. Sine of pi is 0. What is the torque, the magnitude of this force? Well, let's say that this is 10, and let's say that this is 5 meters to the right. The torque will be the magnitude of R, 5, by the magnitude of F, 10, by the sine of 180. But the sine of 180 is 0, so the torque, the magnitude of the torque is 0. What it means this? What it means is, it means exactly that if you use this force to create a rotational movement, if you use this force, this one, the torque will be 0. And what it means that? It means that pushing in this direction, in the direction going to the axis, you don't create rotational movement. Okay? Catch it?
That makes sense, yeah.
Okay, so see this picture also. Let's go to make it like this here. I'm going to show you the magnitude of the torque is the magnitude of R by the magnitude of F by the sine of the angle that they form. Let's say that R is like this. And let's say that F is like this. So you have two ways to see this thing. The first way to see this product. The first way to see this product is you project the F here and you create a perpendicular line to here, and this will be F multiply this F multiplied by this D. Why? Why? Because R has an angle here, theta. This is the angle between R and F. If you put it R like this, R, let's say R, this R, this R, this one, I have put it here. R cosine of theta will be this part, this distance, and R sine of theta will be this distance. This will be R sine of theta, will be the same distance than this. You see it? I repeat it. You don't see it. I repeat it. The magnitude of the torque,
Right.
I've said, is the magnitude of R cross F. Is the magnitude of R cross F. And the magnitude of R cross F is the magnitude of the first by the magnitude of the second by the sine of theta. So I want to visualize what is R sine of theta. Let's go to put it here. Magnitude of R by sine of theta by the magnitude of F. Oh, also I want to visualize what is, so I want to visualize this by this. Also I would like to visualize F sine of theta, this part, by R. Okay? So there are two different multiplications that have to be the same thing. In the first multiplication, I will make R sine of theta by F. In the second multiplication, I will make F sine of theta by R. Is the same, or there is something wrong in what I said?
I think it's the same.
Ah, me too. Me too. So let's go to do both things. I have R like this. I have F like this. Okay, this is the point where the force is applied. So I take the R and I put it here. This is again the R, so forget about this R. This is the vector R. Is this the angle that they form? Yes or no? Yes or no?
Yes.
Yes.
The angle between R and F, this angle theta, this angle theta, this angle theta, is the same angle? Yes, it's the angle between the two vectors. So, first question, what is the magnitude of F
Professor,
sine of theta? What is
Professor.
that, this part? Well, F cosine of theta is this part.
Professor, I
Yes,
have a question. Why wouldn't it be the original angle formed between F and R? Like the obtuse angle.
repeat again, please. What it will be?
Why wouldn't it be the obtuse angle? Why is it that angle instead of the obtuse angle from the original vector R?
Well, because uh, because it's a good question. The angle theta is the angle between R and F. So this is R, and this is F. Can you tell me what is the angle? So to see what is the angle that they form, I need to make a common point. This is R, and this is F. And I see the angle. Maybe 90, maybe 100, maybe 120, whatever it is. So let's say that in my example, this is R, and this is F. I can do the following thing. The first thing that I did is to translate R to here and put it here. But if you don't like this, I will translate the F to R. R and F. And the angle that they form is theta. And theta, this angle, is the same that this one. You catch it?
It always has to be from the tail of one vector to the tail of the other vector?
The angle between two vectors has to be, yes, you can see like this, you can see like this. You put it together, you see the tails of the two vectors, and you see the angle between the two tails. If you want to visualize like this, it's fine. It's fine also. So this is the angle. So I want to make these two operations. The first operation I want to make R sine of theta. And the second operation that I want to make F sine of theta. F sine of theta is this part. F, magnitude of F, sine of theta. Let's go to put here magnitude of F. Okay, magnitude of F sine of theta is F perpendicular to R by the magnitude of R. This is my first equation to calculate. I see the force that is perpendicular to the distance, and to calculate the magnitude of the torque, I make this, not this force by this distance, this force, the F perpendicular by R. The second way to see it is different. The second way to see it is R sine of theta by F. I will leave F like this. I will project R sine of theta. But this is the R. This is the R. R cosine of theta is projected like this. This is R. This is R cosine of theta. And this is R sine of theta. You see, this is R. R cosine of theta is projected here. So I need this distance by the force. So in one case, I limit the magnitude of the force, and I take the distance that is perpendicular, the perpendicular, R sine of theta. So there are two ways to calculate the torque, or three ways, or four ways. Or the best way is tau equal R cross F to make the cross product of two vectors. So let's go to do one example to test it, okay? Example. This is the point 2, 3. This is the vector R. This is the force. In the direction of X. Can you calculate the torque in 4 different ways? So we are going to calculate the torque. So what we want to calculate tau R cross F. But we fix our attention on the magnitude of tau. We'll see later what is the direction of the tau. So first way, the magnitude of tau is equal to the magnitude of R by the magnitude of F, the sine of the angle. Which angle? The angle that forms the force with the vector R. So I will continue R like this, and I will put R here. This is R. And the angle is this one. Okay? And let's go to put it a little bit longer. R. And R sine of theta is this distance. Oh, this distance is this distance. And this distance is 3, because the vector is 2i plus 3j. Oh, so the torque will be R sine of theta, 3 by 10. 30. Second way to see it, B. The magnitude of the torque equals the magnitude of R by the magnitude of F by the sine of theta. So I will multiply these two, and I will multiply by magnitude of R. The magnitude of R is 3 squared plus 2 squared square root. Is correct? Because the magnitude of this, Pythagoras theorem, this is 2, this is 3, this is the magnitude of R. By the magnitude of F, the magnitude of F is 10. And F sine of theta, if this is F sine of theta is 10, sine of theta is this part, by 10 sine of theta. But which angle is this one? Do I have this angle? Can I calculate this angle? Yes. Tangent of theta is 3 divided by 2. So I know the angle. So I can calculate by sine of the theta, of this angle, sine of this angle. And the problem is done. And the third part to do it, that I recommend to do it sometimes, is to do it like this. R is the vector 2i plus 3j. F is the vector 10i. R cross F is the vector I, J, K, 2, 3, 0, 10, 0, 0, equal, if you remember and you see this, the video, you know how to calculate this, and this will be K, 2 by 0 is 0, is 30. 30K, 30 in the direction of K, this is the torque. So you have 3 ways to calculate. So let's go to your book to review what they have done. So this is the first way. The first way, imagine that you want to calculate the torque. The torque here, what is the torque of this force? Well, they make a 0 angle, the torque is 0. This force will not make a rotation. So what is the torque of this force? The torque of this force is the force by this distance, as I have proved you. So it's easier to visualize F by this distance, and this is the torque, okay? So there are positive torque and negative torque. Let's go to see. This force, it will produce a rotation in this direction or in the opposite direction. Well, if you pull in this with this force like this, over this axis, the O, you will generate a rotation in this direction, clockwise. Correct? So I will.
Professor, I don't think I understand the image.
Oh,
So there's 3 strings.
what I say is the following thing. There are forces that produce positive torque, and there are forces that produce negative torque. Negative torque calculated over what? Over the axis of rotation. This is the axis of rotation, this one. Okay? So this force, F, this one, F1, will produce a torque that will tend the body to rotate in this direction, while this force, F2, will produce a torque that will make the body to rotate in this direction, while this one will make in this rotation. So one will create a rotation counterclockwise, and the other one will create a rotation clockwise. So the torque here will be negative, and the one that is counterclockwise will be a rotation that we call is a positive rotation. Okay? So
Is that true for everything? Is it always counterclockwise if it's positive?
always is like this, and it's because we take the angle theta positive through the x-axis positive counterclockwise. If we take the angle theta like this theta is negative. Theta is negative here, while theta is positive here. So the torque go with the sign of the angle. If you rotate, if you make a rotation counterclockwise, the torque is positive because it will be in the k-axis. It will be with the same sign that will give you your right hand side. If you define the torque in a different way, you have to use a rule that will be the left hand side, the left hand rule, instead of the right hand rule. So to be consistent, we always use the right hand rule together with this symbology that the angle that goes in this direction is positive through the x positive axis. Okay? So this is the torque, and let's go to see more things here. You see, this is the right, the rule of the right hand. No, you rotate R. This is F out of page. This is F. Let me try. Let me try to make the picture of F in the plane. Let's say F like this. No, F, and this is the plane where R and F is contained. So this will produce a torque that will be R cross F. And R cross F will go up. This is the torque, this one. This is the finger, that point where the torque is going. If you rotate R, with F. So you rotate R with F, going up. You see it? And this is a screwdriver that if you rotate like this, it will go also up, okay? So this is the equation that I have already resumed. This is the general equation. Let me see if we can do one example from here. Maybe this example. Maybe you can do this example. Do this example. Let's go to do this example. This example say like this. This is a tool that is going to screw and unscrew this axis. This is the axis of rotation. The force is in this direction. R is like this. This is R, okay? This is the vector R, have the magnitude 0.8 meters, the magnitude, and has the direction 90 degrees through the negative axis. And they ask you, what is the torque? Or what is the magnitude of the torque? Can you do it, please? Can you do it?
Okay.
Okay, I'll give you 5 minutes to do it. You can see how it's done also. Okay. When we start with a new subject, it's usual that you get lost because, first of all, there is a vocabulary that you are not used to use. And second, there are new ideas that your brain needs to get used to use it. Otherwise, it takes some time to understand everything. So that's why I want you to give me the one day to upload the videos. You will see more clear what I'm saying, and you will catch the idea. And when you do the problems that I will suggest you to do it, you will feel much more confident. So this part is at the beginning difficult. I know it's difficult at the beginning, but if you make a little bit of an effort, I assure you that you will manage to understand almost everything, okay? So don't be stressed, don't be disappointed at all, just relax. Try to catch the ideas that you can catch now, and after this, see the videos one by one, and I'm sure that you will be in the good path, okay?
Professor, can I ask you a question?
Yes, of course.
How will we be taking the quiz? Is it on Canvas or on a video?
On Canvas, the quiz.
Okay.
So let's go to do this problem. This problem say to calculate the torque. The first thing that you have to realize that is that the torque is going to be R and F is like this. So if you rotate R cross F, the torque will go to my eyes or will go through the screen. Can you tell me?
It's counterclockwise, so it's positive.
It's counterclockwise, it's positive, it's going out of the page. Okay, it's going to my eyes. So the torque is positive, like you see here, and the magnitude of the torque is the magnitude of the force by the magnitude of R by the sine of the angle. The sine of the angle of what? The sine of the angle that makes R with F. And what angles they make? They make 90 plus 19 plus 90. They make 109 degree. So will be the torque, the magnitude of the torque will be the magnitude of the force, 900, by the magnitude of R, 0.8, by the sine of the angle. The sine of the angle they make is 109. And the torque will be this one, okay? And that's all.
How did you get the angle? Oh, wait, no, never mind. Thank you.
This is the force. This is R. This is the force. The force was here. I have moved the force from here to see the angle. And now I know that this is 90. This is 90 degrees. This is 19 degrees. So the angle should be between them, should be 109. Okay? So I'm going to give you is 310. Oh, no, not worth it. I was going to give you a relaxed time of 10 minutes, but it's too late.
You could, you could give us a little bit of time before the quiz, maybe. I don't know. It's up to you.
I can give you, sorry, what?
Like if you ended the class like 10 minutes early or something, it gives people a little bit more time to prepare before the quiz.
Okay, okay. The quiz is at 4 p.m., no?
I believe so, yeah.
Okay, okay, it's today at 4 p.m. It's about work and energy, correct?
Yes, Professor.
Okay, so if you want, we leave it here, and at 4 p.m. please check Canvas, and during the weekend check also Canvas for modules on Unit 6. I'll see you on Tuesday, okay?
Okay. I was just saying like 10 minutes early. You don't have to.
Oh, well, it's the same thing. It's 3:12. Don't worry.
Okay. Either way, thank you, Professor.
Let's take the quiz at 4 p.m. And good luck, okay? Okay.
Thank you, Professor.
Okay, I'll see you soon.
Professor,
Yes.
remember the last class when we talked about my grades and you said that you were going to give us an Excel sheet?
I said that I was going to give you a what?
Excel sheet with all of our grades on it?
Yes, I didn't do it yet, sorry. But
Okay,
I will
will you be able to
let me end it with all what I have first. and I will do it and you check everything, okay?
Okay, because the grades are still hidden. Remember, I had the problem that the grades are hidden.
Do not worry, Ryan. Whatever is not great or is bad grading or whatever, we will review before giving you any
Final grade.
final grade. I will review it again. I will not be crazy doing grades like this without doing everything completely. Okay, so do not worry at all. Anyone, please do not worry. We will review everything. Okay.
Okay, thank you, Professor.
Okay. I'll see you.
Professor also had a question kind of related, but remember how you opened up the homework 412? I received a 0 for that, but I submitted it.
But I have not grade yet.
It says that it was graded 0 out of 2,400 points for me. I'm sorry, but your audio is on mute, I think.
Oh,
Oh, I can hear you now.
what I said that I have not grade this 4 point thing I have not grade.
Okay. Okay, thank you.
Okay, bye-bye. Bye, everybody.
Professor, can I stay to talk to you about my grade?
You need on Sunday, if anyone need on Sunday to make any about any part, be prepared for the exam. You an office hour on Sunday, you just write me, a few of you, write me and tell me what time it will be convenient, and I'm happy to do it, okay?
Okay, thank you.
Okay.
Bye. Have a good day.